Welcome to this explainer. Today, we're going to dive into the absolutely fascinating and completely microscopic journey of how external stimuli actually become our internal reality. I mean, it's a journey that happens inside your head every single second of every single day, yet we almost never stop to think about it.
Seriously, I want you to start by looking around the room you're sitting in right now. Really look at it. Take a brief second to just observe your surroundings. Now, how much of what you're seeing is absolute objective reality? And how much is just a psychological construct built entirely by your brain? It sounds like a philosophical riddle, right? But it's actually just pure psychology.
To answer that, we need to map out the exact process from raw sensation all the way to constructed perception. So we'll quickly cover grasping our sensory basics, the bottleneck of attention, the psychology of perception, organizing our visual world, and finally, depth, space, and daily focus. Let's get right into it.
Starting off with grasping our sensory basics. Let's begin right at the physical boundary between you and the outside world, your sense organs. We constantly talk about the classic 5 senses: vision, hearing, smell, taste, and touch. But you actually have 7. Our sensory basics include 2 deep senses we rarely think about: the kinesthetic and vestibular systems. These hidden systems are constantly giving your brain vital intel about your body's position and its movement in space. Without them, simply walking across the room would be literally impossible. So you aren't just taking in the world, you're constantly mapping yourself within it.
But here's the catch. We operate within strict hardware limits. Take a look at the difference between absolute threshold and difference threshold. Absolute threshold is basically the bare minimum stimulation needed for you to even notice something's there. Imagine dropping a single granule of sugar into a glass of water. You're not going to taste it. You have to keep adding granules until, finally, you taste sweetness. That exact number of granules, that's your absolute threshold. Now, the difference threshold asks something else. Once that water is sweet, what is the absolute minimum amount of extra sugar you need to add for your brain to notice that it just got sweeter? These thresholds totally prove that we don't experience all of reality. We only experience what our hardware is sensitive enough to actually pick up.
Which brings us to the bottleneck of attention. Because even with our limits, your brain is just constantly bombarded with an overwhelming amount of sensory data, forcing it to act as a massive bottleneck.
This brings up a super famous concept in psychology: the magic number 7 plus or minus 2. Our span of attention is strictly limited to this number of items at a brief exposure. And this brilliantly illustrates why the world around us is designed the way it is. Think about vehicle number plates. They're deliberately designed with short digit clusters, typically falling right within this magic number, specifically so traffic police can instantly read and register them in a fraction of a second as a car speeds by.
But what happens when we try to do 2 things at once? Well, we call this divided attention. You might think you can easily drive a car and hold a conversation on your phone simultaneously, but here is the psychological reality. This divided attention only works because driving, for you, has become a highly practiced, totally unconscious, and automatic process. It requires very little active thought. If a child were to suddenly run into the street, your automatic driving would instantly demand intense, active focus, and you would drop that phone conversation in a heartbeat. The brain simply can't process 2 high-level tasks at once.
So how does our brain choose what actually makes it through that bottleneck? Johnston and Heinz's multimode theory breaks it down into 3 elegant steps, showing how our attention acts as a super flexible filter. Sometimes we focus early, based purely on raw sensory data, like, say, jumping at a sudden loud noise. Other times we filter later, based on the semantic meaning, like hearing your specific name spoken from all the way across a noisy, crowded room. It's only after this rigorous, multi-layered filtering process that these representations actually enter your consciousness.
Okay, moving to the psychology of perception. Sensation was just the data collection phase. Perception is where we finally give meaning to the raw data we've just filtered.
So the crucial point here is how we build that meaning. Are we using bottom-up processing, where the parts dictate the whole, or top-down processing, where the whole dictates the parts? Ask yourself, when you see a dog, do you first notice its 4 legs, its furry coat, and its tail, and then logically deduce, yes, a dog? Or do you instantly, effortlessly recognize the dog as a whole concept first, and only then notice its individual parts? Most of the time, our brain relies heavily on top-down processing, using our past experiences to instantly categorize the world.
And because we rely so much on past experience, our expectations can literally overwrite our reality. Think about it.
If your milkman arrives every single day at exactly 5:30 a.m., any random knock at your door at exactly 5:30 a.m. is immediately perceived as the milkman. Before you even open the door, your brain has constructed an image and a reality based entirely on expectation, not on hard evidence. We have a huge tendency to simply see what we expect to see, even when it completely misrepresents external reality.
Next up, organizing our visual world. As we look at our visual field, we discover something kind of funny about the human brain. It actively hates chaos. It acts as an aggressive organizer of literally everything you look at. The Gestalt psychologists proved that we don't see the world in discrete, disconnected parts. Instead, we use a very specific set of principles to instantly group elements into quote-unquote good figures. In a fraction of a second, your brain separates meaningful shapes from their backgrounds, groups similar items together, and actively looks for continuity.
Honestly, my favorite of these is the principle of closure. Through this principle, your brain will literally invent missing sensory inputs to close the gaps in an incomplete image. If you see a triangle with missing corners, you don't perceive it as 3 floating lines. Your brain draws in the missing segments, so you perceive a whole, complete triangle. Your brain actually prefers to beautifully hallucinate the missing pieces rather than deal with an incomplete object. It's wild.
Finally, let's get into depth, space, and daily focus. Think about how you navigate your physical daily life for a second. The images projected onto the retinas in your eyes are completely flat. They are just two-dimensional shapes, like a painting on a wall. So, how on earth do you see in 3D? Well, we rely on 2 brilliant sets of cues to create 3-dimensional space out of flat images. First, we use monocular cues, which only require one eye. These are basically the psychological tricks artists use to paint depth onto flat canvases, like making objects further away look smaller or having closer objects overlap the ones behind them. Then we have binocular cues. These require the actual physiological mechanics of using both of your eyes together to triangulate distance. One of the absolute most fascinating binocular cues is convergence. You can actually test this right now. Hold a finger out in front of your nose and slowly, very slowly, bring it closer to your face. You can feel the physical muscles in your eyes straining and turning inward, right? Those muscles are actively sending a real-time physiological depth measurement straight to your brain. Your brain seamlessly translates the physical strain of your eye muscles into a perception of 3D distance.
Which leaves us with this final, kind of profound question. We've seen how your senses have strict hardware limits, how your attention ruthlessly filters data, and how your perception happily fills in gaps and relies heavily on expectations. So the next time you easily read a license plate, or hear your name in a crowded room, or confidently walk across the street, ask yourself, are you truly experiencing the world exactly as it is, or are you just living inside the beautiful, organized 3D masterpiece that your brain painted for you? Thanks for joining me on this explainer. I hope this thoroughly changes the way you look at the world around you.